boys and girls. What you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
Who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all. And when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence.
Everybody thought I had died and gone to heaven. No, I actually was taking some time off during the summer, and it's really been great to have some time off. But we're back, and we're back with a great subject today, which is dark matter. So yes, you have reached the Saturday Science Chats. I'm David D. Hilster, and we are sponsored by the John Chappell Natural Philosophy Society and Dissident Science YouTube channels, and I want to thank everybody for their support. And of course, today we're going to be talking about dark matter. Is it real or fantasy? Yep, there I am in my funky colored hair again. No, I don't color my hair anymore. So I gave up on it. I said, all right, I'm into my 60s now. It's time to just let it go. So that is me. And I'm here, but I still have my hat, of course. The physics police is always present here. But today we're going to be talking about this, and I do want to thank everybody for their support. It's greatly appreciated, both the John Chappell Natural Philosophy Society, which is in 900s. We will hit 1,000 subscribers easily this year. I'm really happy about that. I want to thank everybody for the support of the John Chappell Natural Philosophy Society. Who would have thought that just a couple of years ago, before we really started this in earnest, this YouTube channel, that when I took it over and looked at it, I think we had 127 subscribers. Now we're pushing 1,000. We'll pass that. So that's absolutely great. And I do want to thank all of my subscribers from the Dissident Science YouTube channel, which I've been doing since 2017. My gosh, so many years. And we are coming up to 4,000 subscribers. So we've got quite a lot of people, around 5,000 subscribers, that do watch this. And remember to always click on the like button and to subscribe, hit that little bell so you'll be alerted when we are going live or we have any other types of videos. So I do want to thank everybody for their support. It's super important. Of course, we are where critical thinkers meet, the John Chappell Natural Philosophy Society, named after John Chappell, who got his doctoral from a prestigious institution. I can't remember which. I got to look that up so I can or put that in there. And we named this society after him because he started the NPA, and we renamed it to the John Chappell Natural Philosophy Society in honor of John Chappell, who is who can consider to be the father of dissident scientists, or really critical thinkers. Really started this group with a bunch of people who were not too happy with special relativity, and that grew into a bigger and bigger group where critical thinkers began to meet about all subjects, including the Big Bang, particle physics, plate tectonics, all of it. And today we have the CMPS, and that's what we are about. Of course, our mission is, above all, to promote critical thinking without malice. Yes, without getting just having an emotional reaction. We're an organization that supports, publishes, and promotes serious scientific work outside the mainstream to provide a forum of open debate and modern topics in physics, cosmology, philosophy, and mathematics, to provide a forum for presenting serious people and theories without fear of censorship. And to be run and controlled in its entirety by our paid membership. So you got to become a member and pay so we can keep going with our endeavors here. Very important, and everybody's support is important. Of course, who we are, we're open to challenging mainstream science, allow and encourage competing ideas or models. That is, oh my gosh, there could be more than one answer to how the universe works. That's one of the big fallacies, that there's going to be only one theory or one model or one set of equations that's going to explain the universe. That's just not true. We also follow the scientific method. I think a lot of people who go, oh, you have your own model of the universe, you just throw everything away and ignore what's really out there, and you don't use the scientific method. Of course we do. I mean, that's ridiculous to even have to say that, but we do. And of course, we can consider an idea without accepting it. Of course, this is not my phrase. This is from Aristotle. He was a member of our. No, he wasn't a member of our organization. Although I'm going to have him talk here one time. I have a live appearance from Newton himself, so don't go away. Yeah, I'm telling you, Newton will appear on this video, on this YouTube, Facebook Live, and will make a statement. It's going to be a short statement, but he'll be here. So don't want to miss that. And of course, we give voice to the voiceless. Those, a lot of times people are not able to go to where they should and talk about what they would like to. And of course, this is where science advances. It always has and always will be, unfortunately. Well, maybe in the future we'll actually have universities where you can challenge everything. Okay, who we are not, we're really not a specific point of view. An example I'll give you that, for instance, is Electric Universe. Love those guys dearly. They do amazing work. They get people who are Okay, folks. I am back. That was really weird. You guys hearing me? Thumbs up. Yes. Thumbs up. Okay. Yeah, it turns out that my computer decided to crash. I needed to restart everything normally, and I did that. Also, it seemed like we lost the internet connection completely, so I think the we had an internet problem. So I apologize. Your stream seems broke. We're good. And let me get back to my talk because I did promise you, I did say, and it is true that Newton will be making an appearance on this broadcast. So um, let's get back to where we were. So yeah, I think as a mission is to here. We're going to get back to our slideshow. I apologize for those people. I did go on a little hiatus here from the internet, but I believe this is where we left off. So let me go ahead and share my screen with audio because we do have audio. Don't want to miss it today. We're going to be talking, of course, about dark matter. So let's get back to it. There we go. And hopefully we will be good. All right. Losing people left and right, I'm sure. Anyways, who we are not, of course, I was talking about we are not a specific point of view. And some group like the Electric Universe, which is a great group, is more geared to the universe being electric. We will accept, and we actually have people from the Electric Universe and many other types of people who have many different ideas of how things work. We're not a general science organization, so you're not going to find us talking about the physics of curling. So that's not going to happen. Also, we're not New Age, and we're not conspiracy or UFO. We do try to stick to fundamental science, light, gravity, fields, magnetism, tectonics, math, philosophy, Big Bang, cosmology, all those kinds of, in fact, topics. So again, coming back, apologize again for the little delay there, but we are back, and we do have our websites Beyond Mainstream, which is our rebranding of what used to be called Science Woke, and you want to check that out. It's an online magazine for critical thinkers. It's a great place to read articles if you are new to the idea of dissident science. And of course, we have our main website, which is naturalphilosophy.org, where our located our critical thinking community, where you can register, interact. You can also become a paying member of the organization to help support these things, because it costs a couple $1,000s or more a year to keep everything going for what we want or what we're doing. And there's also our Wikipedia, and it is closed Wikipedia. That means no one can come in and trash it. Our idea there is to, in fact, have a place where we can put our Wikipedia of natural philosophy and have different ideas out there and put them in a more encyclopedic way. And of course, we know Wikipedia has become, unfortunately, quite corrupt. The people who have lots of money go in there, and they are warriors at trying to put their point of view of the world in there. So we do have our Wikipedia, and that, of course, is using the same exact open source software as Wikipedia itself. We do have memberships on our website at naturalphilosophy.org, monthly memberships, and we do have people who are monthly members, and I want to thank all of those people who contribute monthly. Some are just $5 a month. That's about $60 a year. But if you are maybe a fixed income, or you're retired and don't have a lot of money, you can at least give a couple bucks a month. And we do have people give even more than that monthly. And we also have our traditional annual fees. $35 was actually our older was $35 and $50 for our organization for many years until we got our new modern system, and it will automatically bill you. So once you get into the system, you can put in your information and you don't have to even worry about doing it. We'll just take the money from you. But again, it's very, very important. Of course, we do take donations, and we do get them once in a while. I want to thank very much people who have donated very generously to keep this going. It's greatly, greatly appreciated. And of course, some of our patrons, Nick Percival, Dr. Cynthia Whitney, Ramsey, and all the annual and monthly memberships, we do need your vital support. In fact, without you, we don't exist. I'm not independently wealthy, so I'd love to be able to do this and help everybody out, but we do need everybody's support. So greatly appreciate it. And of course, we're looking in the October timeframe. Yes, I know. I'm working on it right now. We have a general. I'm using, for those people who didn't know, Beyond Mainstream is our new website branding of our online magazine for critical thinkers, and it's got a really great logo. And so I made a T-shirt for that, and you can see it right here. And but we're trying to make a more specific theme. Again, theme doesn't matter. If you have any topic that you want to discuss in cosmology, in physics, in mathematics, philosophy that has to do with science that you can't get published anywhere else, or you've published somewhere else but you want to be part of this conference, you can. You can see here if you get part of this conference what's going to be coming up, and this again will be launched this month. I do have a page for it already. It's not public, and I'm working on that. The fees and all that. Yeah, you do have to pay. It's one of the ways we get the conference, keep the conference going, and also it earns some money for the organization. Of course, when we had our in face-to-face conferences, it was very important because we didn't all do what we do now, which is this whole virtual thing is very, very natural to so many people now. But before that, we had our face-to-face conferences, and that's actually great because you could get away, and for 4 to 5 days, from usually it was from Wednesday until Saturday through Saturday, we would have on-site, in-person conference. We've had them in, I think, in Maryland, close to the University of Maryland, the University of Washington, the University of Vancouver, Canada, Connecticut, Stores, Connecticut, where the MPA had many get-togethers, and we actually had it here in Boca Raton, Florida, where I live. My dad lives, so quite a few people live down here. So we've had that before, but this again is going to be virtual, especially with the second wave of COVID coming along. But it seems like that 95% of people getting it, we're not vaccinated. That's fine. So we're not going to mess around with that. We're going to have our, we're not going to skip for it would be 2 years that we have skipped our conferences. So the way it works is registration will open this month. There will be a fee involved. You will see that because I want to make sure I have our directors, we get together and we approve that. We are working on that right now, and both speakers and attendees will have a fee to pay, and speakers will be able to then, of course, record their presentation and send it to me, and we'll have that available 2 weeks ahead of time so everybody can actually watch them. And then we will be having Zoom meetings to discuss those. So we'll have actually a really short presentation. My goal is to have a short presentation at these Zoom meetings, and the idea of Zoom meeting is to have like a bunch of people being able to talk amongst ourselves like we're in the same room, instead of this kind of thing where you have people chatting and only 10 people can come in. So that's how we're going to be doing it. And each speaker and attendee who does pay their registration will receive T-shirt and credentials mailed to them. If you are overseas, there is a $50 charge on top of it to get that to you if you, in fact, do want them. Of course, you don't have to have them, but for sure, if you are a speaker, part of the fee will be to have your T-shirt and credentials mailed to you. Oops, let's see. Wrong. So you would get the credentials, a T-shirt, and the proceedings, though, however, will be offered worldwide on Amazon 2 weeks before the conference. So that's why we won't have the date set, because we want to give enough time for people. And we do use a system called Overleaf. We do accept papers that are not in the format that we need. We do have a person, my father, myself also, to help out get those into the format you need to do. It's latex. We can help you with that. But if you need that converted, we will do that. But that is a fee per page to do that as well. But most people can do that themselves. We found that it works very well because when you try to make proceedings out of Word documents, it's really, really a pain, believe me. And of course, the publishing is going really great. Notfinity, Matter in Motion, George Coyne's book, which if you didn't see our last video session, it was a couple weeks ago, and check it out, George Coyne, and we talked about the Big Bang and the problems with the Big Bang. His book is available on Amazon, so you can buy that and purchase that. We also have the Ether book by Ramsey. It is available for free. I'll show you how to do that. And publishing on August 21st, 2021, my father and I's book, Principia Mathematica 2, is absolutely coming out and will be available worldwide on Amazon. We'll talk about that too. So the Ether is published, and if you go to theetherbyramsey.com, you can download that entire book. I'm looking to maybe have my father and I maybe present that book because Ramsey, that is obviously a pen name, and the person wants to remain anonymous. So, but they offer that book, and they do say if you do want to go and download load that book at the website, you can see we are help publish this book. My father worked on many years getting it into the format that was needed. And they say if you do download it and you can make a donation to the CMPS, that would be great. So that is sort of a way for Ramsey to say thanks for all the help. We've helped him with the getting his book out there. And again, it's an ether theory. It's different from the theory, for instance, my father and I have. So how can that be? How could we help people with competing theories? Oh my gosh, that's just amazing. And of course, we have the Notfinity, Matter in Motion now available on Amazon. Here's the cover. You want to take a look at that. Really great book. It's the second edition. And huge announcement. Huge announcement. Dr. James Maxlow has a second edition of his book, Beyond Plate Tectonics, and it is now free. You can download the entire book on PDF. Now, this is a book that I claim, and I don't claim this lightly because I've spent since 2008 reading tons of books. I've got books from lots of different people on plate tectonics and geology. I know a lot more about it than I should, even though I'm not a geologist, I'm not an expert, but I consider myself a very well-read person in the area of plate tectonics and beyond, expansion tectonics. And this is now for free. And to me, this is the most important book ever written for geology. I don't see anything that even comes close to it. So I think that if you are a person who is really interested in geology and the idea of expansion tectonics, you have to read this book. It is absolutely amazing. It's over 400 pages. Dr. James Maxlow has his PhD in geology. If you don't know, he was given the mantle of Samuel Warren Carey. He's one of the giants in plate tectonics. For some reason, is still a giant in plate tectonics, but they sort of ignore his foray into expansion tectonics. And he literally in 1994, he wrote a letter to Dr. James Maxlow saying, could you continue my work? Dr. James Maxlow wasn't really interested in that, and he ended up became interested, and then wrote, in my opinion, and became the most important geologist ever. Not of our time, but ever. This book has, if this was accepted in the early 1960s, if you don't know the story, in the 1960s, it was either plate tectonics or expansion tectonics, and people in geology were just freaking out at all about the idea that plates moved or things were changing. They were so freaked that James, I think, rightly said that they had to choose between plate tectonics, which, moving around and not changing the radius, or expansion tectonics, which changes the radius, and they go, look, we don't like either of them. We'll take the one that's less, how do you say, controversial, or less, I don't even know what to say. It popped in my mind what to say. I can't get the words out. But basically, the least of two evils. So they chose plate tectonics over expansion tectonics. If they would have chose expansion tectonics at that time, we'd be living in an amazing place in geology. And of course, his book is probably about 150 PhDs worth of work. I mean, it's totally stellar. Free. Go to expansiontectonics.com. Thank you, James, for everything you do. And interestingly enough, because I love expansion tectonics, we are out there. This is sort of like news. If you haven't tuned in, we'll be talking about dark matter. My talk is coming up, and we got people in our panel which we're going to all talk about it. Part of this is getting the word out. And of course, everybody says, I'm not on Facebook. I don't do Facebook. Well, 116,000 people who love geology around the world do Facebook. And you can see I put something down there. It says, oh, this is one of the reasons I studied expansion tectonics. I put James' book when he told me just a week or two ago that he put it on for free because people were wanting to read it. They couldn't get a hold of it. His publisher trying to get it around the world. He said, the heck with it. I'm just putting it out there. And we had 150 people give it thumbs up going, I'm going to read this, and people telling other people about it. And so this is where the world's meeting, and they discuss stuff. So we have been fighting the stubborn people in plate tectonics. I go in there and I fight for expansion tectonics and James' work and Stephen Harrell's work. He's the one who talks about dinosaurs and their weight couldn't possibly exist with the same gravity, etc. So we're out there fighting. And when I saw this, I said, oh, right, I can put that link to James. And we're out there fighting. He and this one guy are going at it. And it's great to see because the good thing is when you go at it in social media, you're not the only, it's not just you and that person. You're not wasting time because people are watching the conversation and they are swayed by it. And it's amazing. The people who gave this thumbs up are from all around the world. The names in Facebook are just, you can tell their names are from everywhere in the world. I looked at it and so many people thanked me. It's not me that they're thanking. They're just saying, thank me for letting them know about this. So very important, guys and gals. Be out there, be in Facebook because it does matter. This is where we get people to find out about us even here. So my dad and I are here with Principia Mathematica 2. We're going to have a live book signing. You can pre-order our book. People are sending me emails, I can't order your book because I think they're going to Amazon. No, you can't. We're getting our last copy. It's going to arrive tomorrow. We're going to go and look through it before we put this up for real, for sale. And but if you can get all information, if you want to see it, we're going to have a presentation, everything. Go to book.dhilster.com and you will be able to buy a copy of the book, which we will sign live because we're just it's going to be fun. But no, we're doing that because a lot of people know we've been working and doing our work for many years, friends and family. So but we do have people who actually like our model. So if you're interested, you can get your book signed live. That's going to be, if you go to that page, it'll tell you how. There's a little graphic down there. This is our cover. We just added about a week and some ago. I was talking with my dad and came up with this. And our slogan for the book is "The universe is not magic." So this is the cover. And we will be giving it's going to be interesting because we have friends and family and they know we're working on this book. And it's pretty easy to understand, gravity is, hear the particle movements and stuff. But so I told my dad we're going to have to come up with a talk, not for you guys, because you guys know a lot more, but for people who don't know anything about anything usually. And so I came up with this little dummies, the particle model for dummies. So we're going to putting together a slideshow at that. So we'll be doing that slideshow live too. And of course, the 21st of August this month, my dad becomes becomes 84 years old. So happy birthday, Dad. And coming up, of course, we will be giving a talk on that ourselves. I just put that up. I'm not putting up a whole lot of coming ups because I'm talking to people, but I'll tell you, it's like herding cats. People do want to talk, but you never know when. So if you want to be on this program, you can. Just let me know. Give me a topic that you want to talk about. And of course, we'll invite you on. So play today's bumper. Yay, Dave finally gets to the topic after he blumbles and yells. And here we go. Here we go. Make sure I click on the right one. So this is today's talk. Today's talk is something I hear a lot about. I see it in chats oftentimes when we're doing the live shows here, people talking about dark matter. And I have a super bone to pick. I have a thing that gets me upset, that triggers me, and that is we have very good explanations why there should not be dark matter. We actually have we have two papers on it, and we have one of the things I've also observed on it. And I ask myself, and I see people in the dissident community talking about dark matter, and I try to figure out, I said, why are they so fixated on this? What keeps them coming back? Even though we've had papers that clearly show that dark matter isn't needed at all, that things can be explained very simply. So that's what this is about. I just said, okay, I'm getting this off my chest. So what we're going to do is we're going to take a look at the video here that I did a number of years ago, and I think it's going to be really worth it. The shape of a second galaxy without dark matter illustrates something many dissidents have suspected, but few understand: why dark matter is not needed. It has to do with something that the mainstream and most dissidents have not taken into account: the geometry of gravitational fields. And when measuring the speed of stars on the edge, they match with Newton or Kepler's predictions. Big cosmology sees this as the absence of dark matter because they say it is dark matter that causes the stars on the edge of spiral galaxies to behave as they do. The answer to this problem lies in the shapes of the galaxies and not in an invented dark matter. Simply put, the invention of dark matter owes its existence to the failure to recognize that most galaxies don't act as point masses, but are complex shapes creating complex non-spherical gravitational fields. The shape of the two galaxies that don't have dark matter are spherical, and therein lies the answer. Spherical galaxies act as point masses. The Keplerian decrease in star speeds in galaxies are calculated with a point mass, which works well for spheres, but doesn't work well for non-spherical objects. Spherical galaxies have spherical gravitational fields. Spiral galaxies have very complex gravitational fields. Overlaying a spherical gravitational field onto a flat, arm-filled galaxy will never work when trying to understand the speed of stars in a galaxy such as our Milky Way. This graph is from my father's paper and subsequent video talk on his YouTube channel, which clearly shows the discrepancies between a point mass treatment of our galaxies versus the actual star velocities measured in our galaxy. My father points out that one can see the arms and spaces in the galaxy in the graph of the star velocities. The Keplerian drop-off is the curve expected for a uniform gravitational field of a sphere, the exact shape of those galaxies found to have no dark matter. What is seen by big cosmology as anomalous star velocities are in fact
the predicted star velocities from applying Newtonian gravitation to the irregular shape of spiral galaxies. In other words, if you take into account the non-spherical shape of spiral galaxies, the velocity of the edge stars match calculations using simple Newtonian gravity with the existing mass of the stars. No dark matter is needed. Cameron Ribixall did such calculations in his paper entitled Newtonian Gravitational Law over Dark Matter. Cameron first calculates the gravitational field with a bar, then a cross, and then subsequently breaks the cross into arms. What he finds is that stars on the edge of galaxies should move faster according to Newton. No dark matter is needed. It is remarkable to think that big physics and cosmology do not recognize this simple fact. The space industry recognizes the complicated gravitational fields in our own solar system. Take the oddly shaped asteroids and comets we have seen. We certainly know that an object orbiting these strange bodies is not uniform. It can't be treated as a sphere. And we don't have to go any further than our own planet and moon. Probes and spaceships have to deal with a complicated gravitational field when being sent into orbit around the moon. The gravitational field caused by what physicists call a two-body problem is complicated, let alone 100 billion stars that make up our own Milky Way galaxy. Why then does big physics and cosmology not see that dark matter is not needed when we apply Newton's gravity to the non-uniform gravitational fields of spiral galaxies versus spherical ones? The motivation for scientists in having dark matter is that dark matter is much more lucrative and prestigious than no dark matter. The word dark to mainstream science and the public is synonymous with mysterious and intriguing, something to solve and win prizes. In the dissidents world, however, we see words like dark as a red flag for something gone wrong in our theories and models, not something that is waiting to be discovered. A complicated universe brings a lot of advantages to egocentric mainstream scientists. It brings mystery and intrigue to science in a world full of entertainment and distractions competing for our attention. It brings the illusion of genius to those who claim to understand the nonsense of modern physics and cosmology. And finally, it allows for the egocentric scientists to get their funding and lucrative prize money from governments and prize organizations who are run by the very same scientists who perpetuate nonsensical science. If you use critical thought and apply the known equations of Newton's gravity to the irregular gravitational field of a spiral galaxy, you do not need to postulate dark matter. But egos won't let that happen. Too much time, money, and too many reputations are at stake for the current theories to be thrown away. And big science's defense to combat real change is not to allow young critical minds to challenge the foundation of big physics and cosmology. Instead, young people are taught to capitulate to the will of the convoluted and broken scientific model and system that squashes dissent and progress. Luckily, we have people around the world who are not tied to ego, salary, or titles, who truly are looking to find out how this universe works and what theories and equations we can write to best describe what we see. In the end, big physics and big cosmology cannot stop free thought. And with the world becoming more woke thanks to the internet, the science woke, those brave critical thinkers move science forward. Dark matter is not needed. Its refutation is in plain sight in the articles written by the mainstream itself. One simply needs to take the time and apply critical thinking, and the answer is clear.
All right. Well, my goodness, how do I get out of this now? Hello. Next one. There we go. Oh yes. Anyways, a lot of people do miss me doing those videos. It takes, you know, how much time writing a script, doing all the graphics. It is really great. I enjoy doing them, but it's just the time involved is just absolutely mind-boggling to do these kinds of videos. So that's one of the reasons I've done doing these live things. It's just a lot less time. But I thought that was very good. If you haven't seen that, I think that's a really good compilation of my thoughts on dark matter, and we're going to talk about these too. But like I said, we do have a special guest, a special message from Newton himself. So I'd like to play that for you. I don't know how this happened, but I did get it, and he did send me this, and he asked me to play it for you.
Hi, my name is Newton, and I am here to tell you that dark matter does not exist. That Cameron, David, and Bob know what they're talking about, and to ignore them is to ignore them at your own peril. That is all.
I'm sure people are looking at me like you're crazy, Dave. Yeah. Well, anyways, that's pretty fun. They got this software out now that you can make it, how do you say, people talk. But thought that was very fun because it's truly talking about something which is what I'd like to reiterate here and get a little bit more detail about how Newton really can describe what's going on in the edge of galaxies when you don't need any dark matter. It all stems again from the idea that the stars at the edge of galaxies are going at a speed which are not predicted by Kepler or Newton. And the idea is, well, they're not calculating those calculations by looking at every one of the billion stars, putting it together, calculating the abnormal gravitational field that these disks sort of put out there. And therefore, they're doing very, very primitive calculations to try to check the velocity of the stars on the edge of galaxies. They're coming up with answers that do not match a uniform gravitational field. Why would they? And they therefore, instead of saying, well, maybe it's the way we apply things, then, and let's take a look at it again, and they don't do that, because it's much better to postulate something new. I'll talk about that in a little bit. But interesting, as we said before, and I said in the, let me get my laser pointer, in the talk that I did in my video from dissidentscience.com. Again, if you like this stuff, subscribe to Dissident Science and CMPS. But you see this, this is a graph from my father's paper. You can find these papers. Both of these papers I'm talking about is on wiki.naturalphilosophy.org, wiki.naturalphilosophy.org. Look up Bob D. Hilster and you'll see Newton, dark matter versus G. And one of the amazing things he found is that if you look at the plot of the star velocities, you see this, which looks like almost a graph of intensity from if you were to look at the spiral arms. In fact, if you look at, there's space in the arm, you can see the actual arms in the graph of the velocities of stars. If you look here, for instance, they are observed versus predicted. Now, I believe he got this from somebody else. This is not his graph. But if you look at that, well, it may be, if it is, Dad, I'm sorry. But if you look at this, you can see the little undulations there of what, and they just draw a straight line through it. So at that point, they're totally ignoring this idea that, a galaxy, if you send a space probe through a galaxy, it's not going to go in a straight line. It's just not. And if it doesn't go in a straight line, what does that mean? It means the gravitational field isn't uniform. Hello. So, and then this one, I think, again, oh, nope, this is not his again. But if you look at it again, look at that. There it is. So he's saying that, no, it is, the speeds are following, the speeds of the stars are following Newton's laws. It's just that you're not going to be able to do the point mass calculations. So another thing that I found was that I talk in the video is when I saw these a couple years ago, It just hit me like a ton of bricks. I couldn't believe it. They said, we found galaxies without dark matter. And this is a picture of one. What is it? I mean, it doesn't take very much brain power at all to see that we are looking at a spherical, very uniform gravitational field. That in this case, if you calculate its point mass, you would be able to calculate its gravitational, all the velocities. And they go, look, we've got a spherical galaxy, and we are finding that the stars obey Newton's, Kepler's laws. This doesn't have dark matter. We got to figure out why this one. It's really absurd. Of course, just an aside, when I had talked about this before, I've talked about it before numerous times on my own channel, people would say, this is too simple. They would have seen all of this. The idea that that's not no, the simple is not what they want. So, the argument against this idea that it's not a uniform, that spherical galaxies don't have a uniform gravitational field is basically, it's too simple. They would have seen this, and they obviously probably thought of this and then said and went on because it doesn't work. Wait a minute. So where is my, I thought I had Cameron Ribisol's. Let me look here. I'm going to go to my, did I put it? Where is that? Oh my gosh. Oh, there we go. I skipped it. Alrighty. I knew it was there. Okay. Do it from the page. Sorry, guys. I explain what I'm doing here. Go from the page. There we go. And it says, start from this current slide. There you go, Dave. Read it. Software engineer, not reading what other software engineer program. Okay. Newton's gravitational field law over dark matter. This one's a Cameron Ribisol. To me is the paper. This paper to me is a seminal paper in our group. I've told him that many times. He gets all flustered and red-faced and all shucks, but it is. He gave this back in 2016. In fact, the talk's on our website, on our YouTube channel. And basically, he's looking at A, B, and C, the speeds of stars. He starts out with a bar, then a cross. Then he breaks these crosses down into smaller pieces. Then he gets them rotating, and he finds out that the speeds of the stars actually follow what's measured when you calculate the gravitational field of this being. There's a center, there are arms. Yeah, if you're a person that is going to say that's not exactly how a galaxy looks like, that's approximation. Well, guess what? It's a way better approximation than a sphere. So your argument is, no offense, not good. But this, if you want to see this paper in its entirety, in full, go to natural philosophy. wiki.naturalphilosophy.org. I wonder if I have that here. Do I have that as a something I can put up there? No, I don't. I can put that up there. But again, wiki.naturalphilosophy.org. Go to that and you will be able to read this paper in its entirety. It's quite a long paper. It's quite long and involved. So anyways, boy, I skipped that in the beginning. That was the first one I was supposed to talk about. All right, let's keep going forward. And so why do dissidents ignore Newton's explanation for dark matter? Because I know they don't all ignore it, but some of them do. Well, the promise of dark matter by mainstream. Well, they Nobel Prize for those who find it. Absolutely. If you ask Neil deGrasse Tyson, what's the next Nobel Prize? It'll be something like for dark matter once they find it. It's not even a question of whether it exists. And of course, that brings fame and fortune. And of course, no one has found it, but someday, wow, why do dissidents cling to dark matter? Well, mainstream, not all do, but mainstream has no answers. So dissidents have answers. And some, for instance, I've seen some electrical universe proponents. I'm not saying electric universe, the people in charge of it say this. I looked through all their videos. They say dark matter doesn't exist, but they claim that
something else will explain it. It's hard to say whether or not they believe that the phenomena is there that needs to be explained or it's already explained. I'm not clear on that, but I do see people, and often who I know are people in the electric universe, saying, "Oh, it's plasma. Dark matter is plasma." Well, we'll talk about that. But right or wrong, that's what people say. Etherists will say, "No, it's ether." They don't know what's going on, and some of us say it doesn't exist. There's a bunch of us that say that as well. But there are dissidents. So if a dissident explains it, this is the idea. If the dissident explains it, mainstream will come running to that dissident and their theory and work, and work will be recognized and adopted. I think that's why people use names of things to be the same. They say they can explain dark matter with their new theory because they believe that if they can explain it with their theory, mainstream will come knocking at their door and their ideas will be adopted. So dissidents will become the heroes and be recognized. That's really what I think is going on with a lot of dissidents' work. So taking a look at some people's work, like Glenn Borkert, he is an etherist. He, to me, is one of the greatest scientists of our age with his work with infinity. And his 10 assumptions of science. He is written down in annals of history, in my opinion, science. He says dark energy doesn't exist because he talks about this all the time. Not dark matter, dark energy. Energy is a concept. People talk about energy all the time. One of the great things of the NPA and the CMPS, with time, we are all starting to understand that energy isn't real. Put 5 energies into my hand. Look at the units of energy. It's great for doing real world calculations when you're trying to do work, perhaps. You need to find how much of this, what they call this concept of energy is here, which will do so much work over here. Yes, it's great for calculations, but in the physical world, energy doesn't exist. So he talks about that all the time, which he's correct in my opinion. And of course, he did say this about dark matter. Dark matter will remain elusive as long as ether deceleration theory is ignored as the physical cause of gravitation. Now, I'm not sure what that exactly means, but it certainly says dark matter will remain elusive. Again, I think he's one of the great scientists of all time, but his saying that dark matter will remain elusive. Why, Dr. Borkert, who is a great friend of mine. Again, any book that he has written, you should read. Why he says that? Is he ignoring Cameron's work? Is he ignoring my father's work? Is he ignoring that galaxy that I found? That's a good question. Why? That's why the electric universe, dark matter doesn't exist. They do say that. I've seen that written by Walt Thornhill himself, I believe, or at least he said that. Like I said, I can't find anything about EU acknowledging the Newtonian explanation or not. I don't know. I do know that they have changed their minds before, because when we first got together with them in the early 2010s, around 2010, they were sort of chuckling at us. Oh, what's the NPA? Oh, they're a group that thinks Einstein's wrong. Ha ha ha. Now, of course, they have many videos on how Einstein is not correct. So they do change. I have to give them absolute credit for that. But I haven't seen that with them. But I do see proponents of EU claiming that dark matter is plasma. And again, well, we'll talk about that. Jeff Yee, great theory. We're not going to watch this video, but he does talk about dark matter. What does he say about dark matter and his energy wave theory, which he is doing absolutely amazing work? It's one of the very, very few times I've had aha moments, and I've had aha. My latest one was with his work, with his configurations of the atomic nuclei, and putting together Coulomb's law with magnetics, like magnetic fields, to describe the path of electrons following exactly the paths that are happening inside what they say the SPDF orbitals. And it blows my mind that he's doing that. And so I totally I'm a fan of his work. He's just doing really great work. And this is what he says. He has logical possibilities. If you look on his website, energywavetheory.com, I think it is, you'll see under a phenomenon or something like that, you'll find a pull down in his menu about dark matter. And this is what he says. He says a lot. He has a whole page on it. Either dark matter is indeed matter and may not be known particles in the universe, or dark matter is not matter and the observations of galaxies can be explained by parameters in the universe that are variable and not constant. I agree with him up to that very last point, except for that last part of that sentence. Or dark matter is not matter and the observations of galaxies can be explained by parameters in the universe. Yeah, by parameters in the universe that are variable and not constant. I don't know. I guess you could say that a gravitational field that's not uniform would fit that, but he does say that, so that's interesting. Nope, we're going on. Particle model, de Hilster and de Hilster R's. Dark matter does not exist. Newtonian gravity perfectly explains the supposed anomalies. It's a moot point, meaning throw it away, bad idea. And we're not the only one. There are people in our group who believe the same. Questions for us. Well, what if anomalies don't exist that we are trying to explain? This means that alternative explanation for the anomalies are wrong since they don't exist. We dissidents continue to hang our hats on explaining non-existent phenomenon. We use the neutrino and say that's ether. I've seen also the neutrino used as gravitons, where if you look at the neutrinos, Karazani clearly shows how neutrinos were invented to say special relativity, because long story, in radioactivity, they say that you have to have more energy coming out than it's measured. But if you measure the energy coming out of radioactivity, you get exactly what's expected by chemistry. You don't need special relativity and everything works fine. But no, it's got to be neutrinos, and neutrinos exist. And I know, and then I incorporate them. Jeff Yee uses the word neutrino, but he uses it for a different particle, really. Dark matter, gravity waves. So my question for all of us who are dissidents, if you have your own theory, your own ideas of the universe, what if all those anomalies you're trying to explain and get that idea that, I'm going to explain an anomaly that mainstream is trying to explain, and they're going to come running to me for the answer, and they're going to embrace my theory and my models, and I'll get the recognition I need. Well, what happens when we don't need dark matter? And you've spent a lot of time trying to explain it. I tell people over and over, before you claim anything. My dad and I looked months on, does an electron exist? Because if you go back and you look at, it's not like we found an electron with all its charge and its mass and its velocity all just came at once. We never really have seen a single electron, in my opinion, from what I can see from the experiments. We assume it, but you have to be very careful in whatever model you have of the universe before you go explaining things that, in fact, may not exist at all. So, and why is all this happening? Well, mainstream, this is my one of my conclusions. Mainstream really has indoctrinated us. Why? Because the search for anomalies is a search for fame and fortune. Boy, that sentence is it's supposed to say that. But the search for anomalies is really a search for fame and fortune in the mainstream. That's what they say. Oh, wow, if you can explain the anomaly. Of course, that's great, because you do want to, right? I mean, anomalies is where things break down. Absolutely great. But instead of explaining it in current theory, declare a new force in the universe or a new particle. How many times do you see that every year? Oh, there's a fifth force in the universe. Like there are four forces already, and we all agree on that. There's a new particle in the universe. What is it? There's a new one out there. There is a new one where made up of different quarks. I don't know. Why? Why do they do that? Well, they manufacture this. I get this from Chomsky. I'm a linguist, got my master's in linguistics. I work with human language and computers. to me, Chomsky's a linguist. He's the father of modern linguistics, but I guess he also is in political realm. But regardless, he has this book called Manufacturing Consent, which is really true. People will manufacture consent. You put it out there enough, you manufacture the consent that the new force or particle is fact. So if you ask Neil deGrasse Tyson, or you ask Sabine Hossenfelder, the newest of the people who's fallen by the wayside and wants to become who is a science evangelist now, who makes money on her YouTube channel. She went from zero to hero, but has abandoned any hope of actual critical thinking, in my opinion. She and all those other people are going to say, of course it's fact. Dark matter is there. We know it's a fact. The universe is expanding, and without it, dark matter wouldn't expand as fast as it is. All the things that they manufacture, the consent that a new force or particle is in fact a fact. And then they establish that the reward will be great for those who find it. This is how they do it. Higgs boson, gravity waves. And sure enough, they're talking about gravity waves, and they get a gravity wave detector. And it wasn't like 10 years afterwards. That is, they turned it on, and two guys from Denmark who said, oh, by the way, what you consider to be the gravity wave detection that you just gave a Nobel Prize for turns out to be, in our calculations, noise. No, they don't even let it. I mean, it used to be at least they gave 10 years before they would give a Nobel Prize. Now it's gravity waves. We got our detector. It's up and running. Oh, we found one. Nobel Prize. I mean, you can look at that. And so they established that will be great. And so they actually manufacture consent that the new force is found. Don't believe me? Read The Higgs Fake by Dr. Alexander Unziker, a now friend of mine who was brave enough, and he said, I'm not sure I should have written that. It wasn't good for my career. Poor guy. I mean, you got to feel for him in that sense. But if you don't think they manufacture consent about new forces that are found, go look at the supposed way they find and verify particles exist. It would not pass 4 hours worth of tests from any NASA engineer or any SpaceX engineer. Wouldn't. And of course, you reward yourselves, this mainstream has documented, reward yourselves with fame and fortune. So they really haven't indoctrinated us into this whole thing. So it's very easy for us as dissidents to fall into that. Oh, we believe it, right? Hey, it's an anomaly. If we list it, it's all great. So what happens? Well, our facts may match our feelings. I saw this the other day I'm on a whole plant-based diet, and we were talking about, how that is really healthy and reverse my heart disease and all that stuff. And the guy came up with this phrase that I thought was really useful all around. And that's facts match feelings. That is, I have my theory, and I want to describe dark matter, and I think I can. I come up with my explanation for it. So my feeling, yeah, it exists. And so your facts start matching the way you feel about the universe, not that you look at the facts themselves. Because if it contradicts yourself and it contradicts your feelings, then you don't go for it. So dissidents, they buy into the manufactured consent in search of recognition and acceptance. Dissidents to ignore facts like current gravity equations explain stellar velocity at the edge of galaxies. I mean, I gave you some examples. I won't repeat them. I'm not here to crucify anybody, but there are people out there who say, yeah, it's there. And dissidents' response to this claim that the galaxies are the velocities of edge stars on galaxies are explained by Newton. I do not see anything, I do not hear anything, I do not say anything, because I don't hear about it. I hear people, I'll say, we know why, we can explain all that stuff, and then the person looks at me, and then they continue to tell me how they can explain it in their theory, and I'm like, so what do you say? So that's my spiel today on dark matter, and I'm going to bring up some people here that are in our green room, do some discussions. If you are in the chat, and I see lots of people just doing lots of chat stuff. You can ask a question or do a comment by, I'll put that up. Either start it with a question or a comment. I'll be watching those. But I want to bring some people up. I'm going to bring, first up, my father, and that is a person that I did talk about their work. I don't have Cameron with me. I wish I did, but I'll just bring him up and talk a little bit. I think you're on mute, Dad, so I'm going to bring you up. If you can unmute yourself, and let's talk a little bit about. I just want to talk to you about your foray into your paper and talking about dark matter. How did you come about that? What did you find? Why did you do it?
Well, yeah, I wrote that one paper. I don't know what year it was. I think it was maybe 2012. But in 2009, in Stores, we were at the NPA conference. I had two papers. And I rushed right through all the two papers. I presented them, and I literally said to the audience, I said, "I'm sorry, I apologize, because I want to talk about something else." And in effect, what I did was bring up the anomalies, namely anomalies and dark matter. That was in 2009, and all I had was, I didn't have a paper. No paper to back it up, just a slide presentation. And I had a chart, and I can't remember anymore what it is. I don't know if I even have that slideshow anymore. But I actually explained why dark matter didn't exist. So way back in 2009, which was only like 2 years after I started doing this science with you, that I came up with it. But when I did write the paper, then 3 years later, 2012, I had really looked at that a lot more carefully, and finally hit me with the shape of the curve. And in the presentation that you made, there were 3 graphs. None of them are mine. And I showed multiple graphs in my paper, if you go read it, because I did pick one to emphasize, because it was it stood out more in terms of making the point. But but what hit me finally was that the shape of the curve was telling me what the shape of the galaxy was. And right, that's fine. Okay. Something with my voice just happened.
I don't. Oh, I know what it is. Yeah, hold on. Let me get this off. Thank you. Now it should be okay. That was something. Franklin, Hugh came here just to remind me again. Turn off the audio on your sharing screen stuff. I can see him in the green room looking at me. Dave, how many times do you have to do that? So yeah, it should be better now. Does that sound better?
Yeah, it does. Okay, so I have a pointer too for some reason. If you look at this curve, if you're standing on the center of the galaxy, assuming it's a solid piece that's spinning, and you're on the north end, on the north pole of that, you're going to have zero velocity. You're going to be turning at a speed, but you're not orbiting. So it starts at zero, goes up to the peak. Now, to me, at that point, you're standing on the equator, assuming the center is a solid piece that's elastic, spinning, has an equator. You're standing essentially at the equator, and that's maximum speed. Okay, and then what happens is you go into open space between arms. So that falling part, the falling part, actually is a form of R square in that region. And then you hit the arm and it builds up. So the rising part is the arm, from there to the peak and back down to just to the peak, I believe. And that's the first arm, and then it falls again with open space. Then you got the rising as the second arm, and then whoever did this curve just draws it straight out. That's just too remarkable to, and yeah, that's none of these are mine. That last one, the previous other one, that was in my paper, and I picked it because it's almost identical, and it shows you the data points. Quite remarkable that you can see the shape of it in the velocity curve. And I remember the time I walked up to you, David. We were in California, of course, at the time, and I walked up to you and I showed you that, and I said, "Dave, look, we can see the shape of the galaxy in there." That was a really, to me, a great observation. Maybe I'm wrong, but I'll bet you if you go through and use Newton or even our equation for gravity and apply it to our galaxy, calculating the velocities, that's a huge, very complex problem to do. Nobody wants to take the effort to model the core and the arms in such a way that you could actually duplicate that curve.
But somebody did.
Well, yeah,
I'm sorry.
I don't think he did it quite that.
But he did try to model it, which was heroic. It was really heroic.
Yes.
Cameron's work, where he did this work, is heroic. Go look at the paper, folks. It is not easy. He did it really with it's not like a model that you have where you're calculating, gravity as particles going in all directions and putting the masses in the way. So.
If I might interject at this point, if I could have the time, you were talking about anomalies. I was having lunch with my other son, Michael, in California one time, and we were talking a little bit of physics, as it happens in our family. And Michael was the one who said to me, "Dad, there are no anomalies." So I've come up with a new word, if you will. Nature does not anomalate. I mean, that's a form of what Mike was saying. Look, nature doesn't make mistakes. Nature is what nature is. It does what it does. The real problem is we use anomalies. Some people use anomalies as a way to excuse it and say, "Oh, that's just an anomaly. You don't have to worry about it." Other people finally realize you got to worry about it, so we work on it. In our book, we have a section on the Wang eclipse in which I use the particle model to explain the Wang eclipse, the gravity measurements during an eclipse. And it's a very interesting explanation, and I recommend those because that explanation, I did make a video of that. If you go to my videos, you'll find search on the Wang eclipse. You'll find the explanation. That explanation is also in the book. But the other, I'm not going to go into detail. The other word I don't like goes along with anomalies is aberration. Aberration of light. It almost makes it sound like light is doing something wrong. Well, light doesn't do something wrong. Again, light does what light does. So there are no aberrations in nature. The problem is we have observations that don't match our predictions. Mm-hmm. It's a human problem. We have calculations that don't match our measurements. These are discrepancies, not anomalies, not aberrations. They're discrepancies because of our predictions and observations don't match. Our measurements and our calculations don't match. And we call them anomalies or whatever. We set them aside And fortunately, good scientists going to know you can't set it aside. You got to resolve the discrepancy.
Right.
My statement.
Okay. Well, thank you very much for, whoops, wrong, pushing buttons. Thanks for coming on. We just brought him on again to explain his journey of the dark matter. Here's some comment I found here. I think my father can watch these comments. We'll hopefully put them up or collect some of them here. Here's a good example of one here. Dwayne Mansell, ether is at least plausible as dark matter. Again, my question is, are we just going to ignore work like Cameron's work or Bob D. Hilster's work? Do we just say, oh, that doesn't matter, dark matter is there? I mean, I'm not sure what that kind of statement is. It's sort of like, yeah, it's plausible. And is this a case where a person is saying, this is a way for us to show that ether is really there, that of course, ether is not accepted by mainstream science. I'm a person here that will tell you that ether is is impossible. It is absolutely a possibility that there is an ether. I don't believe there is, but it doesn't mean that I'm not God. I'm not. My word isn't magic. So understood. But when you have a statement like this is exactly what I'm talking about. Ether is at least as plausible as dark matter. So we can explain all these supposedly events in the universe, which aren't anomalies, where those are the way the universe works. We can explain it. We don't need dark matter. So why would we want to add dark matter to explanation that needs no extra thing like a dark matter? So that's very interesting. Let me see here. Anyways, in the green room, we have some people who'd like to come up and speak about this topic at all. I see we have Franklin, we have James Keene, Nick Percival. Franklin always will talk about it. He's a trooper. Hey, Franklin, how are you?
Oh, good. Yes, I've been kind of monitoring the chat going on in dissident science, which seems to be quite involved. So
Yes.
there have been a couple of issues brought up that I think were interesting.
Okay.
Just for example, the role of peer review, or why is it that us dissidents don't like the mainstream, right? So why is it we don't like the mainstream, and how is it that we're qualified to even say anything about these topics if we haven't been properly trained?
But then again, what properly trained means if you ask mainstream, is for you to accept their explanations, right? So
well, it's more like, if you don't have a degree from, XYZ university, then, you're not really qualified to do that. And then when you try and publish a paper about something, and, they won't, I tried that just for laughs. I said, okay, I'm going to send this to, XYZ proper journal, and of course I get back the summary letter saying this is not something we're interested in, response, right? So therefore the way we would never allow anything say mentoring,
right, but again, what I'm saying,
whatever.
Take Stephen Crothers, for example, okay? Stephen Crothers went in with a perfectly, literally wanting to work on black holes because he thought there were problems with Schwarzkopf. I never get that right. Somebody can correct me on that, but on the equations for black holes. So he went in there and, he can take all the classes and everything. But once they discovered what he wanted to write his thesis on, didn't happen. So the problem is they require you to have, the argument they give is they require you to get X. They don't allow you to get X. And then they tell you they're not accepting it because you didn't have the degree.
So the only way you get that degree is if you say to them, you'd have to sort of lie to them. You'll say, of course, yeah, the black hole calculations are great, and you get your PhD. And then afterwards you rebel. You then say, I want to write my second PhD and I want to criticize these. And they say, oh, we have no one here that will let you do that. And in fact, they kicked Stephen Crothers out. So, the argument that is a valid argument that you don't have a PhD in physics isn't valid if they do not allow you to, once you get that or during getting that is you pass every test. They hand you a test in your PhD exam that you do calculations with general relativity, even if you do not believe space-time and all that, you pass that. But if you're talking to them about your thesis to say black hole calculations are wrong, they don't support you. They kick you out. So I don't see how that argument can hold water. It's not a legitimate concern because they make an impossible
one of the points that's kind of being made is that, if you're educated, then you have a better chance of, understanding and explaining things, which is true. But I would say that as amateur dissidents, we have the major advantage that we have the internet. And, I can just type in my little search on just about any particular area that I'm interested in, and I could, literally bring back all of the entire world's knowledge about that particular thing and become an expert on, say, that particular thing. And so that you don't necessarily need to be a university professor. Even if you've been a university professor around for 50 years, I can probably bring up more information about any particular topic faster than he could ever done like 10 years ago. Right?
Sure.
So
No, I agree with you.
That. I mean, for my work, I try and do as much research as I can. I think that's my advantage, is that I can bring up data from everybody, even the crazy people, at my fingertips. So that gives us a great advantage, I would think. So, but yeah. I mean, there were some other interesting discussions about, why is it that dissidents don't agree with mainstream, and so it was brought up that whole thing about explaining what gravity is by using the rubber sheet analogy. And then I would point out that, that rubber sheet analogy requires gravity, right? If you try and do that experiment in space shuttle, it doesn't work. Why is it? Because that particular explanation is completely circular, right? It's not actually an explanation. So I'm just trying to say that there are a lot of explanations like that, which, we accept. We right. seem to think they're experimentally based. But, when I ask the question, if this is so, then, cite me one real piece of experimental evidence that shows that the rubber sheet is there, but there isn't. It's completely a story.
Yeah.
But getting back to what you were doing there with showing that the dark matter doesn't exist. I mean, to me, what is very convincing is a picture of that spherical galaxy, which does not have dark matter. I mean, I think that should be patently obvious to the most casual observer that the shape of the galaxy is what is causing this.
Yeah.
And some of the discussion was saying, oh yeah, that's accepted. That's like modified Newtonian dynamics. But I would look that up, and it's like, well, that's also kind of an empirical law, as bad as dark matter, right?
Sure.
What Cameron was doing, or what your father was describing, which is to try and do a detailed analysis on every single particle in the sun. I believe that if you were to do a supercomputer analysis of every single thing in the properly shaped flat galaxy, that hopefully it would calculate out to be exactly what we observed.
I think that
Newtonian gravity.
I think one of the problems is they did that, but they used a point mass. They didn't use a gravitational field that they didn't put a gravitational field around the 100 billion stars. They were just so enthralled with the idea that they could do so many calculations, but they did not put a gravitational field around each one of those. They just did a calculation in the middle and then calculated all the movements like they do sort of in computer graphics. When you see the computer graphics that look like explosions and stuff, the way they do it in like Blender, even the way Jeff Yee does it, is you have a particle and you have equations, then you act upon that particle when you move it. Those equations will then tell you the next place it's moving. So
I'm reminded of the spherical cow joke, which is that, the farmer had a problem with the cows and he asked the physicist, and the physicist started out, well, let's assume the cow is a sphere, right?
Very good. I've not heard of that.
What they're doing here is that they're presuming that, the flat galaxy is a sphere.
Right. Exactly. Yeah. Well, and here's one of the things
up with, by calculus, if you have a bunch of mass that's spherical, you can treat it as if it were all concentrated in the center, which is, good math for things which are spherical, but it does not at all apply to things which are flat. So
right.
I would totally agree with you. I mean, I think it's, probably pretty obvious dark matter doesn't exist. It's just in order to prove that, another point was that, people know about these things, but it's a competing theory to say dark matter, because we're still doing expensive dark matter searches, right? We don't even know what it is, but how can you search for something that you don't even know what it is?
Well, they do that all the time. So, in fact, one of the comments here was talking about unicorns. I'm going to put this thing up that you had mentioned, something sort of like that. We were talking about whether or not, how can we as dissidents who are not experts, who don't have PhDs in the field, after spending 8 years on my documentary film, Einstein Wrong, I tried to come up with a phrase, my own phrase, that would describe what is unique about the MPA and now the CMPS. Because one of the things that I realize is that, and I think you know this too, you've been to many of the in-person conferences, you and I, right? And when a person steps up to that podium, the last thing on your mind and my mind and everybody's minds in that room is, oh, what's your degree in? What do you know? We don't care. We are going to listen to what you say. We don't care what your title is. We don't care if you got a PhD from MIT in special relativity, like Cynthia Whitney actually has. We don't care if you're a person who's never been to school. What we do is we listen to what a person says, and we don't listen. And so I came up with this phrase at the end of my film where I summarize it. I says, don't listen to me, listen to what I say. What that means is, who cares who I am? I care about what you say, because that's what it's all about. And that's the problem of universities, is they don't do that anymore. If a person stands up in class and says something brilliant, and they're a psych major, and they say something brilliant that could change all of physics, a person says, well, you got to come to our physics department and learn all that stuff. Your idea may be great, but, sorry, you don't have a degree. So if you really look at our organization, that's really unique. No one cares. I mean, if you go to almost any other talk, right? You go to a talk with people who do brain surgery. Oh, we got this guy, who lives in his car in L.A. underneath a bridge. He used to be a person who worked at this company in this factory, but he's been thinking about brain surgery and has been reading all about it, and now he's going to give a talk. It's not going to happen. Whereas in the CMPS, you send us an abstract, you send us your paper, and we then say, oh, this is very good. And do we check, do we reject a person because they don't have the credentials in it? I mean, we accept, Duncan Shaw, he's a lawyer and the Supreme Court Justice for Canada. And what do we do? Get his paper and say, it's on Ether, and say, well, Duncan, we'd love to have you, but you're a Supreme Court justice. What does that have to do with people like us who have studied physics all our lives, So, but you're right. We don't have, we have everything that the human race has ever thought of right at our fingertips. And
I heard Elon Musk say that we are actually all now superhuman because we have these cell phone things. We're carrying a supercomputer in our pocket and we have access to the entire world's knowledge. So we have in fact become superhuman.
Yeah, yeah. Okay, well, thank you very much, Franklin, and thank you again for everything you do for our organization. And we have other people in the green room. We have James Keene is there. Dennis is not here. I know Nick is there. If you want to come up, let me know. Wave your hand. And also, we do have our comments. Let's see what we have some here. Theory, listening to these. Maybe my dad, if you see any there that put up question. Here we go. I see a question. Again, if you want to put question or comment, we will put it up here. I think I may change the way we look at this branding. I think I can make this a little bit bigger. So let's do that. Yeah, let's see what this looks like. Nope, we'll go with this one here. Okay, where can I read David D. Hilster's papers, please? Okay, well, you can read all of our papers. Let me put this up here. You can read them in two places, not just mine, but everybody's. I'll just have to type them in. I should have these things there, but whoops. Let me put this up. You can read them at db.naturalphilosophy. Two places, naturalphilosophy.org, and also there we go. So you can, this is one place you can find them. There's another place which is maybe a little bit better, naturalphilosophy.org, and that is at wiki.naturalphilosophy.org. You can also find our proceedings if you go to Amazon. You can find the CMPS's proceedings there and order the books. We don't make them expensive. The idea is to get people to read them, so you can go and look at them. They're not going to have anything. You can have abstracts, but that's one of the reasons we do the proceedings. But all the proceedings that we have had since we started the new organization in 2015 are available, so you can look at that. But in the wiki, Natural Philosophy, I believe we have over 2,000 abstracts, at least the abstracts, many of them with links to actual papers of people's work outside the mainstream. So that's where you can find them. Let's see, anybody, again, if you're in the green room, wave your hand. I will go down there. Somebody, okay, I see that. So let's bring them up. There he is, Nick Percival. How are you, Nick? Again, thanks for all your support and what you do. And if you haven't checked it out, Nick of Time, you should check it out. Subscribe to his channel, watch it. He's got over 30 videos. Very interesting, especially if you like relativity and time, just time, which we all are curious about. How are you, Nick?
Doing good, thank you. I just wanted to read a comment that I put in the private chat as my comment. Mainstream physics academia has replaced the scientific method with a new paradigm. Namely, academia derives theory via math manipulation. And if the empirical data does not match academia's theory, they do not question accepted theory, but rather they try to bridge the gap between the data and the theory.
Okay.
But rather they try to bridge the gap between data and academic theory and treat it as a math problem, as how to resolve that gap. And after deriving the math solution, they give it a name to represent a physical entity, e.g., dark matter.
Well, look at that. There's a slide up on it already there.
Okay.
So people can read it. So, so the scientific method with the new paradigm. So that means that even though they tout the scientific method, that really it's more of, what would you say? It's more of political motivation than a scientific one? How would you characterize that?
People have compared it to religion or a philosophy. In other words, relativity has just become a belief system that is unshakable. And
Right.
and for some people, it's kind of tied to their own personal ego. They've been praised so much for understanding relativity, which is supposed to be one of the highest pinnacles of intelligence and human thought. So if that's proved wrong, and they've been preaching this for 30 years, it's like it's a personal attack on them. So they have this belief system that the currently accepted theory in academia is true, and therefore they don't question it.
Yeah. Yeah. I think this idea that we had talked about before I talked with Franklin is that they say you need to be trained by them, and in order for you to be be accepted by them. But to be trained by them, if the only way to do that would be to fool them into thinking that you believe everything they say. And the moment you would then go off and say, now I want to write my PhD on, how relativity is wrong, all of a sudden you aren't accepted. So they put in these impossible situations for you to attain. The only way really you can get to where they want to be is to believe and push what they believe, and then you are, of course, accepted. Even though I really and truly believe that that the average person isn't, the average student isn't necessarily believing everything, but they'll do it because they want to get their position. I know this because when I did my movie Einstein Wrong, I was in a classroom where I filmed with my mom for a couple of days on the advanced physics class, many of them going to pretty prestigious institutions. 50% of the seniors said they would forego truth to get their position.
Yeah.
I mean, this is high school. I mean, it's really quite amazing. And we want the idea that we should have academia in a place where we are open. I mean, why is it that computer science, you come in and you want to disrupt, the world and the internet with a new app or a new computer language, whatever it is, that's all rewarded. But you can't do that in physics or cosmology. I mean, why is that? Is it money? Is it you don't make any money after, I guess, from it? I mean, if you come up with a new particle, you're not going to make money off of it. I'm not sure. So what is your take on dark matter yourself?
Yeah, I believe it simply is a math invention that allows them to say, oh, our theory didn't explain this or predict it. Therefore, we have to build a new layer on top of our currently accepted theory that's compatible with this currently accepted theory to explain it. That way, we don't have to modify and say that our theory was wrong or had any imperfection. And you can see modern physics, particularly on the area of so-called space-time physics and cosmology, building layer on layer of things that have been derived purely by math, but have no counterpart in physical reality.
Yeah, yeah.
And one quick comment on the neutrino.
Yeah.
They have so-called neutrino telescopes, but those telescopes don't claim to view the neutrino directly. What they view is the interaction with the alleged neutrino and other particles.
Mm-hmm.
But this neutrino telescope follows the sun, and goodness knows how much stuff is coming out of the sun that will cause this type of impact and creation of other particles. So it's a misnomer to call it a neutrino telescope.
Yeah. Well, if you look up in the Wikipedia neutrino, they have a picture, and the picture of they have I think it's a muon maybe.
Yeah.
But and there it says, this is a muon that used to be a neutrino.
Yeah, that's exactly it. That's what I was talking about. Yeah.
Right. So that's never been observed. The neutrino, Carasani explained very elegantly why It was postulated. And then when I've talked with neutrino people, and I asked them, I said, well, if you look at the origin of the neutrino, it's to save special relativity. They go, no, it's not. And I said, yes, it is. And if you look back on the history, it's there, but you can't find it because they don't write that part into it. If you go into most of the books, you do not see that. One of the things is you have to go back to the original letters that Pauli wrote to Fermi and those things, and you will see they were going to name it the neutron and then et cetera. So yeah, it's really a house of cards. So, okay. Thank you. Any more comments or?
That's it.
That's it. Okay. Remember, folks, to check out The Nick of Time if you are a person who enjoys a time. He has a great, really great series of videos talking about time and relativity. So I do see lots of interesting comments here. We wait for each other. They're clumped together in groups. Yeah, I know there's a lot of talk about redshift. And I think one of the things I see somebody here, Mrs. Donnelly, and she is talking about how it's observed in the lab. This is another thing. I don't know if this person's real, Mrs. Donnelly. I'm not sure that's really her picture, but of course in the internet world. But regardless, this is an interesting comment. We literally observe it, so I don't understand what you are talking about. Now, this is one of the problems in science, is that it's not a skeptic of everything. We all can observe gravity. We all can observe lots of phenomena in the universe. We can measure stars' velocity along edge of galaxies, calculate that they are actually following Newton. We can do those kinds of things. But there's a lot of things that we say we observe in the lab. Now, the question becomes, is that verifiable? I'll give you an example. Gravity waves. Gravity waves were supposedly detected. The math was given and the data was out there. And two physicists from Denmark disputed those findings. They disputed the findings that the observations, we literally observed gravity waves, were in fact not an observation of gravity waves, but just part of the noise. That the claim that these were coming from, you have all kinds of assumptions that go on top of the statement that we literally observe these things. And that's one of the problems we have. We hear this, for instance, another one, relativity is proven every time we shoot off, for instance, a atomic, in the atom smashers, the Large Hadron Collider, Stanford Linear Accelerator, we observe relativity working all the time in the sky because we measure whether there's exoplanets by using general relativity. Well, again, those are assumptions, and you can answer them with a different answer, and that is where the problem lies, is that we literally observe it. We do not believe you are observing what you are observing, or we believe that what you observe is nothing at all, like the gravity waves. And I think that's, again, one of the huge problems we have with science. We tell them, for instance, they don't tell you that, by the way, every time we shoot off the particle collider, the atom smasher, the Stanford Linear Accelerator, we show special relativity wrong every time we do that. They don't say that. They say it's right. Well, it's not true, because in my movie Einstein Wrong, I have a experimental physicist at Stanford Linear Accelerator looking right into the camera saying, we do not observe mass increase. I have to unteach my grad students special relativity. Oh, but we observe it all the time. The statements that you get from people that this is, we see it, we see in the lab, you can't dispute it. We've had this verified by people all around the world. It's just simply, something that is disputable. And so that's
these kinds of statements can be very frustrating to see. Okay, we have people in the green room. Please wave your hand if you want to. Oh, I see it, person. Hello, Harry. How are you, Harry?
I'm fine, David. I have a bit of a quibble with your presentation.
Sure.
And my quibble is that I'm not really sure what your point is. I'm not really sure whether you're challenging the existence of dark matter or what exactly. But the argument is based on making a bunch of assumptions. They use a bunch of assumptions in astronomy. And you didn't tell us what those assumptions are. There's plenty and tons of assumptions. And any one of them could be wrong. Okay. And that leads to this conclusion that the model doesn't make the correct predictions.
I did make that.
The model involves a lot of assumptions.
I made one assumption, yeah.
Data derived from these assumptions goes into the model. So the model data could be wrong. And then they say, well, we don't agree with the predictions, so therefore we have to have an ad hoc assumption. I think we talked about that the last time where he talked about all these ad hocs. You remember that?
Sure.
All the ad hocs there are. Well, this is an ad hoc.
No. Let me explain. Said very in the beginning. The assumption is that the gravitational field for a galaxy is spherical.
Well, you're claiming that's the one assumption.
That's how they calculate. That's how they come up with the idea, and that is how they come up with the.
I'm not really sure that's correct, David, but you're presenting an alternative by saying that particular method of calculation, assuming the gravity is spherical, is wrong, and yes. You're presenting a couple of people who have done calculations that say that they can find the
spherical galaxy mainstream says it doesn't
assumptions. I'm not really sure that mainstream hasn't explored that. That needs to be addressed. I think that question came up in the chat.
Yes, I've heard.
But there's a lot of assumptions, and main assumption is that the Big Bang is correct. Okay, that's an assumption that they have in there. From that, they deduce that that what's produced in the Big Bang is hydrogen primarily and helium to a lesser extent. Then that condenses into stars by some process which they haven't really been able to pin down very well. And then this condensation process forms galaxies. Okay, and the stars condense out of this gas. Okay, that's kind of an assumption that limits their models to a certain extent. So they've made a lot of assumptions, and that's a big assumption there that their whole theory of galaxy formation. So their theory of galaxy formation kind of constricts their models and how they do the calculations. So basically, you could interpret this as being their whole theory of star formation and galaxy formation is wrong, because when they apply all those assumptions, then they have to have this ad hoc hypothesis of missing mass, which they've converted into dark matter. Actually, the original name of it was missing mass because they couldn't find where this missing mass was. So what happened to all this missing mass that's supposed to be there that's not there? Well, it had to be there originally, right?
Well, I think if I understand the history of it is that I think they put those things together from different places, that the star velocities on the edge of galaxies was one thing, and then the whole expansion where you talk really about redshift and the Big Bang, and then they're saying that it's accelerating. It's not just even a constant expansion, and that accelerating expansion.
Preserve the big model, which is the Big Bang. So their assumption is the Big Bang is correct. Right. Their next assumption is that galaxies are formed by the condensation of gas produced by the Big Bang, and the gas is primarily hydrogen and helium, and not as much helium as hydrogen. And then from that, they try to say, well, galaxies are formed by a condensation of gas. Sure. Now, that means that you only have a limited amount of mass to start with. Okay.
Well, there's also
So, now,
I understand.
their calculations don't work out. So there had to be some additional missing mass, which they call dark matter, to make their calculations work.
Well, they also have the acceleration part, though, is part of it, because they did not say before, they were saying it was expanding. As time went on, you heard mainstream say that it's not only expanding, it's expanding faster. And then they even say each time they say it's expanding even faster. Now, where those things come, I'm not really sure.
Well,
So,
but right now, by the time we get to this point, we got a whole bunch of ad hocs that are
yeah,
already in the mix. So we got ad hoc, is what is his name? Coyne, is that the fellow's name that said that? I like that
George.
phrase, ad hocs. We got a lot of ad hocs.
Yeah, exactly.
And
Yeah,
this is another ad hoc. That's really
yeah,
basically this dark matter missing mass. It's an ad hoc. They can't
hmm
explain something. It
right,
doesn't work in their models, and so
right,
they invent an ad hoc hypothesis so that they can preserve all of their other previous assumptions about the Big
yeah,
Bang existing, the creation of how galaxies are created as a result of the Big Bang. They've got all these models, and they all have to fit together. And then suddenly, oops, this doesn't fit anymore. So we need an ad hoc.
yeah, yeah, absolutely.
So
No,
I
I
think
agree
the
with you.
whole point here is that missing this dark matter is just an ad hoc assumption that goes
Yeah,
into the mix of, and reason people don't believe it is because if you're an outsider and you're not 100 convinced in everything that they're saying, then you just perceive it as an ad hoc. So basically, I perceive it as an ad hoc. They don't perceive it as an ad hoc.
yeah,
So
sure.
that's really, I think, what the issue is. Why doesn't mainstream perceive this as an ad hoc assumption?
Well, because I think that's part of their entire model for the last 50 or more years, right? If you look at, I don't know, did you read the Higgs fake by, uh,
No, I haven't read that, but that's
yeah,
basically my point. My point is, to me, this looks like an ad hoc assumption. So I'm not convinced, but I'm not an astronomy professor. So,
right, understood.
I
Yeah,
mean, my
understood.
opinion doesn't really count, apparently.
Well, and again, that's part of, well, for you to be part of an astronomy professor, you're not going to get through their astronomy program saying that dark matter is ad hoc. They're going to go, oh no, that's okay. That's okay, Harry. Keep going with your. So this whole idea that you're not an astronomy professor is, for you to become that, you have to stop with your critical thinking, a lot of it. And I think that's, I'm not
So
sure
your
what that.
argument is that in order to become an accredited scientist whose opinion would matter in developing the consensus, you have to believe in all the ad hocs.
Yes. And if you don't, Stephen Crothers is a great example. He went in with intentions to get his, I don't know if it's PhD or master's degree in astronomy, and he was wanted to show the mathematics and the concepts behind the calculations for black holes were just fraught with problems. And he was literally drummed out of the university. He told he couldn't come back. I mean, so I understand. I think the problem is when we put up this idea that ourselves, we critical thinkers who aren't in the universities, who do not have a PhD, it would be really interesting, in fact, to listen to what Cynthia Whitney thinks, who got a PhD in special relativity from MIT, what that means, what kinds of statements, what does that mean? Is that a valid statement? Because if the thing that's being held above us and our opinions and our work is that we don't have the degree, yet they create an impossibility of that ever happening, how can that be an obstacle if you say that it's impossible for you to get to where they want? So they say you got to get to the land of X for us to listen to you, but you can't get to the land of X is if you have these particular criticisms. So for us to then say we're not in the land of X and therefore what does our opinion mean? How can you get there? I think that in itself is a artificial barrier that is something that we go along with, and I don't know if we should. I don't know.
All right, I want to just sort of finish off here with when I was at Johns Hopkins Applied Physics Laboratory, and the reason I mention that is because I know that was in the 1970s. That was about 1975 to 77, I think. I read some of the original papers by Vera Rubin, and I thought this was rather astonishing stuff. This was before they had invented the ad hoc of dark matter, and it was talked about as missing mass. Now, that was about, let's say, 1975. So that puts us 25 years to 2000 and another 21 years. So we're almost talking about 50 years. How many years is that? 46 years?
Yeah. Yeah.
So that's a long time for them to, solve this problem. They haven't solved this problem. They've been looking for this missing mass, dark matter for quite a long time. And, I just don't think it's credible that if you've been looking for something for 40 years, almost 50 years, and you couldn't find it and you're still talking about it, I would say it's pretty questionable as a scientific concept.
Yeah, no, I agree. I mean, that's one of the telltale signs, but it seems like, today, I think there's sort of an opposite going on. At least I was pretty shocked on the turnaround from gravity waves to Nobel Prize. Usually, if you look at history for Nobel Prizes, right, you would have a discovery in 5 years, 10 years, after the community sort of settled in and said, yeah, this is really something that's worthwhile, that then a Nobel Prize would be given to them. But now it's like, you're in the Nobel Prize grind. As soon as that Higgs boson is found next year, Nobel Prize. It doesn't seem like, on the opposite side, you also have that. It's like, find it, discover it, accept it, manufacture the consent that this is real, give them the prize. Very opposite of what you're talking about, which is how many years has this gone on with haven't been able to find it, and you hear them repeat over and over that if you do find it, you're going to get a Nobel Prize. So yeah, I agree. All right, well, thank you very much for your comments. Do you have anything else before I?
No, I think the issue is this really a believable concept based on all of the assumptions that they need to put into the mix?
Yeah, I agree. I think that's a very good point. The idea, I guess, Harry's saying is like, look, you have all these assumptions that you're making to get to these points. And one of them is the Big Bang, because I didn't talk much about the expansion and expansion of the big, the universe and the acceleration of the expansion, and therefore the dark matter is needed. But the assumptions made, and the idea that the word black, dark matter is itself gives you the idea that it's somewhat ad hoc. It's like this dark, mysterious thing. It's and I agree. It is. I agree with what he's saying. So it is a good point. Anybody else in the green room there would like to make any statements? We got a few minutes left, but anyways, I guess not. Again, if I want to thank everybody for their support, do remember to hit the like button, folks. If you do like at least what's going on, if you think this is a stimulating conversation, a place to be, there's nobody else talking about these things the way we talk about them on the internet. So, let people know about us by clicking on the like button wherever you are. Also subscribing to the channel. I think that also is helpful. I want to thank all the people who are part of the CNPS that keeps this going. We do hope, my goal is to, by the next time we meet here, video-wise, that we will be going full swing with the registration of our conference. And I do encourage you, if you have a paper, then to contact us, and we will be putting that together. So we do have a conference coming up. And again, the format's going to be, I think, for 4 days, 2 days during the week and 2 in the weekend. That way we can catch everybody that we can. And I want to thank our people who came on today and talk with us, and everybody in the chat. Your contributions are very welcome. So let's get ourselves out of here. We got 2 minutes before we go. Let's play some of our exit videos here.
And remember, folks, remember what I always say. Stay critical, stay thinking. I am David D. Hilster. I'm your science therapist trying to get you to the promised land of becoming a critical thinker. Ciao for now.